Hello everyone, I'm Anna and I'm happy to be here today with you with jconf.dev and share with you how you can let Kubernetes batch that for your Java application. A little bit about myself. I started and I'm still Java at core, but I also like untangling the mysteries of Kubernetes and how Kubernetes works on environments like OpenShift or IBM Cloud or on-premise, for example. I certified the second passion, of course, with various certifications in the cloud area. But what I mostly enjoy regarding Java, Kubernetes, and the technical world is sharing these kind of experiences and experiments with different communities, like the one that I co-founded together with Victor Rente at Bucharest for Craftsmanship community. In here, I'm sharing in my native tongue, Romanian. But I probably in the future we're going to expand the contents shared within this community to English as well. That's enough about me. Let's talk about the topic of today. The topic of today came as a result of the fact that a lot of applications that exist nowadays were not written yesterday with the latest technology and the coolest things around the market. They were written some time ago and they work perfectly, some of them at least, and they're considered old or legacy. And we should also take a pick on these type of applications and how we can reimagine them in this new cloud native context, in the Kubernetes context, and how this can be shifted and can be working great in this new world that we're in. Also, some historical facts that I want to share with you. Some of you might be aware, some of you might have not be aware that batch processing was introduced as part of javaEE 7 platform within the JSR 352 specification. And it meant quite a breakthrough at the time and nowadays because it defined the programming model for batch applications plus a runtime and how to run and manage the batch jobs. I can say that that meant a great deal for me because I was a developer working on javaEE 6 and then moving to javaEE 7. And when working with batch applications, that meant a lot for me as in terms of improvement of my work and making things easier. And secondly, for those of you that are not aware of what batch applications or batch processing means, batch processing means perform a long-running operation or operations on a bulk data, do it that automatically, and doing it on demand or a predefined schedule. Back in the day, things were used to be done as follows. So whenever you needed to process a lot of data, to prepare a lot of data that was in a format to be usable for your application that uses a different format or a different data model, you used to have this kind of batch application. And you wouldn't have done this processing within your normal monolithic web application. You would have done it separately in an application that ran independently that was preparing this data, so you would not affect the performance of your own web application. Also, based on my experience, I synthesized a few batch job capabilities. So first of all, it should process a large amount of data. You should not employ or thinking to employ a batch job unless you have to process a lot of data. And by a lot of data, typically it's a lot of data in a database that needs to go through a different data model and look different, or a lot of files. Secondly, it should be initiated on demand or a predefined schedule. Also, in the past, there were batches that were initiated through processes and approvals, and those are on-demand jobs. But the best jobs are batch jobs are the ones that can be ran on a predefined schedule because you let the operating system run that for you. Also, from my experience, I remember that I had to log at each computation and data manipulation I was doing. The reason being because I had to make sure that when I was doing that data manipulation and computation, the data that I was processing was, the input, the amount of data in input was the same amount of output. I was not, missing any record upon that data manipulation. Secondly, I had to constant check on long-running operations because when you're making a batch job, you kind of observe, depending on the amount of data that you're manipulating, how much time it will take, right? So when you do that, you can kind of anticipate how much time an operation should take. And you should check that if that operation is running optimally or not. And if not, then you should think on how you can recover and restart because maybe a failure occurred. So also because it was running with a large amount of data, and sometimes the data that even existed in databases was not necessarily in the all in a clean state or in a clean expected state. Failures can occur because of that. So you have your batch application. Your Java batch application should have this ability to recover and restart when this failure occurs. Let me talk about the anatomy of a batch job that JSR 352 has introduced to the world, regardless of framework. So, first of all, we got the job repository. Job repository means where all your batch jobs currently be running or that are to be ran are available. The job launcher is the one that is using the job operator API to interact with the job repository and with the jobs, of course, and it pulls out a job from the job repository and is actually running it. The job can contain one or more steps. Depending on the complexity of what you have to do with that batch job, you should have had one or more steps. And these steps can be comprised of an item reader. I mean, it is reading the data from a predefined source. The item processor, the one that is, processing the data, and the item writer, the one that writes the data to the predefined source. That's about it with the talk for the moment. Let's see the code. Going in IntelliJ, and we're going to start with the javaEE batch. I have a simple javaEE batch. And before going into the cloud-native way of looking into it, my simple javaEE batch has the definition in an XML. So in my XML, I specified the job ID, it's simple batchlet. It gets a property called wait time based on how much time it should wait before it actually starts. And it does some internal processing. It logs some data. That's not very fancy. It's not very complicated in its work, and pretty much it. So I didn't want it overcomplicated. However, you should note that this batch job, because it uses javaEE, it is not yet in any way connected to Docker or Kubernetes. It needed a runtime that provides the javaEE for it to run, right? So this job, the results of this job, this WAR application should have been working on application server. So let me start that application server in dev mode, which is the Liberty one, MVN Liberty Dev. I'll start my batch to run for you. But if I'm thinking of moving this batch to the cloud-native way, some of you are going to say, because it's quite simple, and besides the server dependency, it doesn't seem to have any other dependency. I first need to create a Docker file. So first of all, I'm going to say java8 from, and this part here is going to run my build. So I'm going to say simple javaEE batch. This one builds my app, and then I need a runtime that works well with this job. So I'm going to use the Liberty with java8 runtime, in which I am going to copy the contents of the previous build result, this one here, the WAR file, and I'm going to copy it in the drop-ins. And there's the server.xml configuration that I used to have in my local, and I used to start my local server, that I also want to copy because I want to make sure that, well, the things in the cloud are running as expected in my application. And then the run configure.ch is the entry point for my Docker file. This entry point is coming with the Liberty image, so it's not something that I've done. It comes with the image itself, the OpenLiberty image itself. So let me go to the command the, actually not the command line, sorry, here, and see how the batch is doing. So you can see here that the batch started, it executed, depending on how many times I'm running it in the browser. Going back here, I want to move this to Kubernetes, so I already have the Docker file. Let me look in how do I put this to Kubernetes. So I'm going to use a Kubernetes job resource. The reason being is because this is the indicated resource when I want to talk, when I want to work with these kind of applications that should work as an atomic unit of work. And I'm going to explain a little later why I chose this and why is this resource should be chosen instead of deployment. But for the moment, let's look at this definition. So this job, this Kubernetes job, I'm going to give it a name. Let me see. It should be, I'm not very creative. Let's see. I'll say single pod job. The image for it, if I'm going to go to the terminal, Docker images, yay, there are my Docker images. Yeah, simple javaEE batch, this one is. Going back here, let's give a name to this container and say javaEE batch. And the container port, I would say 9080, because I want to keep the container port that my server is running on. Since I'm moving this to Kubernetes, I don't want to go again in a browser, invoke this endpoint, because it's a little bit annoying to go and do this manually. So I want to automate this more. And also because I would like for my job to be in a completed state and not to be in a running state so that I can go to the browser and click on it. So I'm going to create a sidecar container that's going to run for me a command, a curl command, that's going to invoke the job. And it's going to do the work that I did previously manually in the browser, but I need this URL here. And yep, I think we're done. One more thing that I want to tell you is that I specified the completions and the parallels for this job to be only one, because I want only one pod to be ran for this job, nothing more. I want to do the job once, that's it. Okay. Now let's go to the command line, to the terminal. Okay. Clear. I'm going to say kubectl create -f cates single. And yeah. And I have my dashboard of Kubernetes running, but of course it kicked me out because I didn't interact with it for some time. So wait a moment. kubectl delete job -. Doing it again. I put a space. Okay, so the job is being created here, and let me look inside it. Okay, then we go here, and then let's look in the sidecar. Yep, it works. Sorry, I looked worried for a moment. Yeah, so my sidecar invoked the job. Now, going back to my presentation. So you saw the modernized batch. The modernized batch, what it did, it is the one that's suited for managing isolated atomic units of work. So you could have seen that it ran an atomic unit of work, meaning one pod, one job, and that's it. But what is most important is that it can do that reliably and that shut down the container. And by shut down the container, let me go back in the browser, you're going to see that the pods are terminated and completed. The pod is terminated and completed. So this means that we executed successfully, it's done, it's there, and I have the warranty that everything worked successfully, and I can monitor it really nicely through Kubernetes dashboard. So this is about the way of the modernized batch, the improvements that the modernized batch is giving. Like everything is being now decoupled. The app is decoupled from the scheduling framework, and it's everything very atomic, and the shutdown is performed once the work of that container is done. Now, there are several approaches on working with Kubernetes job resources. So one approach is to work with one job per work item. And this option is really good when you have to define each work item as you have a complex task per work item, and you have to track that and scale that independently and record that in Kubernetes independently. So this is pretty much when you should use this approach, because this, be aware of this approach, because this one is Kubernetes resource consuming and should be done carefully when working with batches. Now, the second approach is the one when you don't need to record or track or scale independently each work item, and the work items are managed from within the application via the batch framework. Like in our case, because that was our case. The batch framework was already there for us. The batch application was already done in Java, so there was no need to tell Kubernetes to have like one job for each work item that was comprised at the level of the batch job in Java itself. Now, regarding the jobs in general, there's the single pod job. Like we had earlier, the spec completions and spec parallels values are set to 1. When you need to do that atomic once run command. So it's pretty much the equivalent of the on-demand job, but it's on demand like you're putting Kubernetes via the sidecar container to run that job for you. Then there's the fixed completion count jobs when you already know the amount of work items that you're going to have. And you discover that if you set a parallelism completions to a larger value than 1, you get a better performance from your job. And this means that the processing cost of a single work item justifies the use of dedicated pods. And of course, there are the work queue jobs that are pretty much this strategy is more indicated when pods should coordinate among themselves, and this means that your pod contain images or containers that are communicating with each other through messages. Now let's go ahead and see the fixed completion count jobs with Spring. So going back to IDEA, and I have another batch application that's called Cat Adoption Batch. And this one, what it does is processing an XML containing the cats that can be adopted from a shelter. And the processing it is done as follows. If a cat has more than 1 month, then it can be adopted. And the adopted cats are stored in a CSV. So the batch is getting as input an XML and outputs a CSV based on a business rule. That's pretty much the description of it. And this is a very natural Spring Batch application, no Spring Boot in it. I have kept everything like it used to be done before with Spring version 3. So I have the context defined in an XML. I have the job defined separately in an XML, and you can see here that this kind of job is a chunk-based job that is using the XML item reader to read from the XML, the CSV file item reader to write into CSV, and of course I have to find my own filter report processor that is doing all the processing part for me. Now, if you're looking just for comparison how things are showing in the class diagram, this is pretty much it. And this is my Cat Adoption Batch application that is being manipulated via XMLs and is using this part here to process data into CSV. Now, if you're looking, this is a javaEE Spring Batch app. But if you're going to go and look into the modern way of doing this, so how would the modern way of this application look like? Well, it would be based on Spring Boot, obviously. But what I did for my Spring Boot part I just kept the cat adoption batch application as it used to be. I annotated with the two annotations Spring Boot application and enable batch processing so that I can justify, okay, you're going to use batch processing, you're going to in a Spring Boot way. But I also want to use the command line as well, like it used to be in the other case, in the Spring Batch one. And I moved the configurations that used to exist at the XML level in a batch config in the batch config. And I'm specifying my input and output XML, and my input XML and my output CSV via application.properties so that I can configure that from the environment regardless of who is, doing the manipulation of environment variables, and regardless if it's Docker, if it's Kubernetes, or any other orchestrator. So those being said, if path input.xml is not defined, it's going to take the XML on the class path. Same for the CSV, but it's not the case. Cool. Then we're gonna go here. Let me make a small comparison of before and after. Let me split to vertically. Okay. So let me show dependency. So you can see here that this was before show dependency. So this was before and now this is after. The only thing that changed is the batch config, but the rest of the things are pretty much the same. Nothing has changed in regards to this. Now, on this kind of application, since we modernized it and we moved it to Spring Boot, we're also going to use a Docker to Dockerize it. So again, I'm going to start with from, and I'm going to say cat adoption batch. So pretty much the same thing as the previous one. The only thing that changed is that for Spring, I'm going to run it differently. It's going to be a jar app, and I'm going to copy it from the previous build, and I'm going to run it through the entry point.ch. So the other one had the configure.ch given by the runtime of Liberty. This one, I created my own to manipulate the Tomcat runtime. And I don't want to run it as a root, so I'm going to use my own user for this one. So, ta-da! This is pretty much it with the Docker file. It's quite easy, quite simple to Dockerize, and I don't think it takes a long time. Now moving forward to Kubernetes, because we're talking about resources like files, for example, to be stored, and you need to store them somewhere. So I use the persistent volume called sample that can be accessed via a persistent volume claim called CSV report. And this is where my XML and CSV files are going to be located in. So I'm not going to use storage inside my pod that's going to be created by the job. I'm going to use storage outside the pod so that I can persist this data thoroughly. And now let's go and see the job for this one, because this one is a fixed completion job job count situation. I'm going to instruct my job to run 4 pods, but it has to run 2 pods in parallel. So I want for my job to do this in chunks, like 2, 2, 2, 2. Now it's 2 and 2 because there are 4 pods. I'm using the cat adoption batch image, which is resulted of that Docker file, container port 8080, the debug port as well, and then we have the command to start the job. So the command to start the job is java -jar. It's pretty standard and easy. And I've given the output CSV location to be at CSV report.csv, and this one, it stays on the persistent volume. And the way I've managed to do this on a persistent volume is by mounting the volume via its persistent volume claim here. So you can see the path here CSV is the same with the mount path here /CSV, and this transformer volume is actually referencing my persistent volume claim that was created earlier. So I'm chaining everything and I am decoupling as much as I can. So this is pretty much the word that I think that it defines the modern job and the modern batch job, decoupling. So now let me go to the command line again and go to cat adoption batch after. And I'm going to say kubectl create -f cates fixed job. And this job was created. Let me look here. And let me look to the pods. So you see it runs 2 pods in parallel. And it's going to do their work. They're going to do their work pretty much like more the command line. So they do their work, they run. And you can see now that the job is completed and the container is being created. So once the pod is completed, it gets to creation of another one. In the meantime, I want to access the data that is written by the by my job. But since these containers are in completed states, I cannot access through them the data there. So I'm going to create a helper pod through which I will copy the information in report.csv, that is my persistent volume. So I'm going to say helper, mount path is /sample, and PVPVC, CSV report. Cool. So I'm going to create my helper pod as well. Clear. kubectl create -f cates helper. And I'm going to say kubectl get pods to see. Okay, they're all completed. So I'm going to say now kubectl cp with helper from the sample report.csv path report.csv. So copy this on my local. And now I'm going to go here in my folder, and I'm seeing that I have my report.csv copied in my local, and the job did its work. Now, I talked about scheduled jobs as well. So how are scheduled jobs working? Scheduled jobs, well, it's pretty easy. I'm going to reuse the, split vertically. I'm going to reuse the contents of the fixed completion job and transform it in a cron job really, really quickly. So first of all, I'm going to use cron job as an object, and then I'm going to use the different API version because that's one beta 1. And I'm going to use casecat to add the what's extra, and that's it. Ta-da! We have a cron job. And this cron job has a few things extra, like job template, schedule when to run this job, the concurrency policy if this this job should be ran, the pods should be ran concurrently or not, failed job history limit or success history limit, and pretty much that. And let's go to the presentation. So we saw the parallel batch job execution. We saw that the first 2 of them were executed, the first 2 pods were executed in parallel. And then once those were done, the next 2 pods were executed again in parallel. So this is pretty much good to do parallel work, to execute things in parallel, and it helps a lot with those chunk batch jobs that used to process a lot of data. Next, on the scheduled jobs, what we saw is that they need a definition on when they should be running by using the spec.schedule. If, by the way, the job doesn't start at the scheduled time, you should use the starting deadline seconds, like after how much time after the specified schedule it should start. If it did not start before the concurrency policy, if it should be suspended, if something is wrong with it, or if you want to introduce a way to test your job. And of course, successful and failed job history limit based on I don't know, the records that you want to have for your job, how many were successful, how many were failed. Beware of these limits, because the higher you set them, you are going to use resources of Kubernetes as well when you set these two. And those being said, my final thoughts on this presentations are that you should assess the strategy for your job and cron job based on how you can run it, if it should be concurrently or not. I mean, those pack completions and parallels, how to set them. Also be aware that the job and the cron job are also using memory of Kubernetes. And as before you were thinking on how you were using the memory of the operating system, where you were deploying your job and the cron job, or the memory of your application server, right now you have to also think in a predictable way for working with Kubernetes as well. Jobs have to handle also the dependent job failures. If job failures occur with your job resource or cron job resource, you should be able to handle that through your job, so be aware of that. I've done that in my jobs, by the way, so look at the example. And you should delete jobs that can no longer complete. So jobs that are in stalling mode, that they cannot complete, you should be deleting those. No worries, you don't lose anything. Thank you everyone for watching this presentation. You have the samples here in my GitHub account, and I hope that you enjoyed the rest of the conference, and see you soon. Bye.